Okay, quick overview of what are quantum numbers and what do they mean. So just to give a quick overview, electrons, we have to understand, do not behave like the usual physical objects used to seeing in everyday life. And I guess I can even use this as an example. So I toss the pen up and it comes back down. And it just goes up and down. But this is not small enough to behave in the quantum way that electrons do. And electrons exist only at certain energy levels. They cannot exist in between. So imagine if, in adding energy, this behaves like an electron. Instead of up and down, imagine if I toss it up and it disappears, and then reappears here, and then disappears, and reappears here, and then disappears and reappears here, and then it disappears and reappears in my hand. That'd be quantum behavior, where it cannot exist in between two locations, such as boom, 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 and that's it. So in order to describe this unusual kind of behavior, we need things that are a little different from what we're used to in regular everyday life, and that's a quantum number. So, well, let's start with this. Quantum numbers specify things like energy level, orbital type, spin, also kind of like orientation, things like that. And there are 4 of them, and you'll write them with this format. The parentheses is optional. I kind of use it sometimes just to make it stand out as being a quantum number, but it's optional. Okay, the numbers are what's the important part. So essentially what I need to do is go through kind of like what each of those numbers means. So there's the principal quantum number, tells you what energy level it is. That L, that second number, tells you, it's the angular momentum quantum number. It tells you essentially the shape of the orbital, tells you what kind of orbital. It is almost like a code where different values for L mean it's a different kind of orbital. The magnetic quantum number, it gives you, essentially it's kind of like the orientation of the orbital, sort of. Real quantum physics is rather complex stuff, but this is sort of like what it means. And what we can think of it as is we draw electron diagrams with those little boxes and those series of boxes, sometimes for the P and D and F orbitals. This is sort of like specifying which of those boxes it belongs in, with each box having like a different address. And then the final number, that S, the spin number, is direction of spin, up or down. Spin, it's kind of a funny thing because they don't actually spin, so they're not physically spinning, largely because these things are so infinitely tiny that in order for something to spin, it has to have a surface that's rotating past you, and these don't occupy 3-dimensional space, which means they don't have a surface between, there's nothing rotating past you. But they produce an electromagnetic signature similar to a spin, and for various other reasons it essentially comes down to, they have this thing that we can call spin, even though it's not literally spinning. Anyway, it's either plus 1/2 or minus 1/2. This means spinning upward. This is the arrows that are pointing upward in the electron diagrams or the orbital diagrams. This is the arrows that are pointing downward in the orbital diagrams. Now, found there's a video online that involved a guy explaining it like this. And instead of like those orbital diagrams, we kind of drew them like all in a row or something. You can kind of arrange them in order of like how they're filled. So think of like a electron configuration, or it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, whatever. And you arrange them in this order like this, from lowest energy that's filled first to the next highest energy that gets filled next, to the next highest energy gets filled after that, and so on. Here's another way of looking at it. So this is filled first, then this one, and then this one, and then this one. So that's why you have the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, etc. The reason why we do it in that order is because that's from the lowest to the next highest and higher and higher and higher energy. That's how the order in which they get filled. So let's do an example of how do you actually apply quantum numbers to this. Okay, we can say, look, here's an electron that's right here in this orbital, this area. What are its quantum numbers? The quantum numbers will describe essentially its location, and what we're going to look at is that formatting that looks like this. So I'm going to kind of block these out because I want to just emphasize N, L, M, S, where N is the energy level. In this case, it's 3. The L is you can think of it as being kind of like a code for which orbital it's in. It's a d orbital. S orbitals are 0. P orbitals are 1. D orbitals are 2. The position, we'll call the middle position as 0. Minus 1 plus 1, minus 2 plus 2. So position -2 over there on the side. And then that upward arrow means positive 1/2 spin. Okay, I mean, yeah, the answer's right there. But I just kind of wanted to go through why this leads to this. If you want to put parentheses around it, fine. If not, fine. It doesn't matter. It's just, I do that sometimes to make it stand out a little more. Let's look at another example. So get these out of here. Oh, yeah, final answer. Yep, good. So we can do this likewise with here. Same thing. So, viewer, take the moment, pause the video, solve this, and then check to see for the answer. Which I'll assume you have now paused the video. And final answer this. Energy level 2. P orbital is 1. Position 0. Spin minus 1/2, as indicated by the downward pointing arrow. Okay. We can also do it the other way. So if I give you the electron, say find the quantum number, I could also say, here's the quantum number, find the electron. And, okay, that would be energy level 4. So that's either this, or this. Orbital number 3, okay, that's a 0, that's a 1, that's a 2, that's a 3. So F, somewhere in the 4F, plus 2, that's here, plus 1/2. Oh, come on, pen, right. There we go. There we go. I guess the computer agrees with me.